Hi guys, welcome to Learn Electronics Repair. This is the bipolar transistor gain tester or measurer that I built. Had this on the previous video a few weeks ago, and this was because I have an amplifier. This is one of the channels from the amplifier which had a pair of blown transistors, and I wanted to see if I could match some transistors with the existing ones. The problem is that I actually couldn't. I'll link that video to this one in the video description if you've not seen it. But basically, the way this tester works, we just press the green button and we take a reading, and by doing a little bit of maths, which I will show you again later on this video, we can work out what the gain of the transistor is. And this one was about 133, as I remember from the other video. So I couldn't find any that match these. Most of these are very closely matched. There's another pair which are not, which may have been changed previously. Maybe somebody else has repaired this before me and it just failed again, and that could be because of this mismatch. So I have here a batch of 10 transistors. Okay, these are all from the same batch. These are not from AliExpress or online, these were bought locally. Okay, so we can see that these are all the same batch number if you like, and I'm hoping that these all have very similar gains. So let's take the measurements, work out what the gain is, but it doesn't particularly matter what it is. It's more important that they're all very similar to each other. You've probably noticed, by the way, that these are all NPN devices. This tester will actually test PNP as well by reversing the polarity. But this amplifier has all NPN output stages, so there are no PNP in the output stage, okay? If you're wondering how that works, by the way, very brief description, but normally you'll have NPN and PNP devices, and what this does is it replaces the PNP also with NPN, and then it inverts the phase of the drive to those. So effectively they switch on when the PNP ones would have done. Yeah, and this is done, I think, to better match the two sets, because although you can get a matching set NPN and complementary PNP, you can guarantee the PNP ones won't have the same gain as the NPN because the manufacturing process is a little bit different. Okay, so enough of that. Let's get these measured. Let's see what we have, and let's see if we have a set which are good enough to put in here. Then we'll put the amplifier back together, and let's see if it then works or if there are some other problems with this. This is my bench power supply, dual supply, plus and minus. I have it set to plus and minus 5 roughly at the moment. I adjusted it with the other transistor so that effectively I get 2 amps flowing through. So switch it on, you see 5 volts. Okay, here so that's plus and minus 5. We hit the green button and that's practically 2 amps, very close. And on here we read 1.73. okay, if I hold it on, by the way, as the transistor warms up, that will decrease a little bit. Okay, but we'll say 1.73. To work out the actual gain, we need to divide the collector current, which is what this is showing us, by the base current. In actual fact, this is showing the emitter current. It's slightly in error, but it's close enough for what we want to do. So we're not measuring the base current, we're actually measuring the voltage drop across the base resistor, which is a 10 ohm resistor. So the base current is actually 0.173 divided by the 10 ohm resistor, 0.017, so about 17 milliamps, 17.3 milliamps, and we divide the 2 amps by that. So 2 divided by 0.0173, that's the gain, 115. So what I'm going to look for now is how close the other ones are to that, and I shouldn't have to work them all out. If I get something close to 0.173 on here, I know it's close enough. So that one gain was 115. This one 0.189, so it's not the same. Let's see how much that affects it. So 2 divided by 0.0189, 105. I've tested all of those transistors, so the 10 that the guy brought me said they were all matched, but they're not. 8 I've removed from the amplifier. You can see those are the ones with the bent pins on. So those are the 8 that were not short on the amplifier. And then 2 more I already had in stock as well. And this is what I found. So these are the closest matched ones I can make out of this. Now I've put them into 2 sets. So I'll put one set on one side of the amplifier, one set on the other. So these range from 121 to 126 gain. Possibly not absolutely ideal. In fact, it isn't absolutely ideal, but I think that's going to have to be close enough because that's the best I have. And these go from 126 to 130, which actually sounds like a larger range, but it's less. So there's 5 difference between the highest and the lowest here, and there's 4 difference there. So they are pretty well matched, I think. Would you agree? Because I'm not an expert on these, although I am becoming one somewhat, yeah, with your guys' help and the amount of these things I'm getting to repair. I have 4 which are in this range, not particularly close, between 72 and 83. I have 4 more between 109 and 115, and I have a couple at 105, and then I have 2 more with much higher gain, yeah. So those are the ones I'm not going to use now. I will just mention that all of these transistors are within spec. So the spec I think was from 70 to 150 without milking it up again. It's something like that. And they're all within spec. They're just different values within that spec. So these I'll keep just as spares. At least I know what the gain is marked on them now, and maybe be able to use some in another job or put them together with some more that I get. It's not ideal fitting back in the ones which were off the amplifier where I had a shorted pair, because you could quite validly raise the argument that these have been stressed as well when the failure occurred. But given what I have here, I think that is probably like the lesser of the evils. That's my opinion, or maybe I'm hoping, but that's where I am with it. So it's kind of like best case out of what I have. Again, I'd be interested to hear from you guys who've done a lot more of this type of work. Would you believe until I had this channel, I was never an amplifier repair tech. I have fixed 1 or 2, I will say, back in the day, or 3 or 4, but I'm not an expert yet. Okay, let me know and let everybody else know what you would do in this situation. Or would you just say, not good enough, I need to get some more? Okay, down there. I'm going to fit these in the batches in which I've shown them, and let's see if this amplifier channel actually works now. I've fitted all of the transistors, 121 through to 126 on this side, 128 to 130 on that side. I don't know if this actually makes any technical sense, but it just seemed reasonable to me that I put the highest gain ones next to the thermal sensors. The idea being that the ones with the highest gain will switch on first, if you like, as the waveform passes near to 0. Yeah, it passes sort of through. So they technically are doing the most work. Whether that actually has any effect on the thermal trip out, I really don't know. I'd imagine because of the thermal mass of this thing, it probably doesn't make a lot. And that actually just brings me to something interesting. So this thermal compound, I've been using this for a few years. I think I bought a pack of 10. I have 1 more tube left. I used to use Servosol, but I can't find that on AliExpress, at least. And it did occur to me, I was just having a look for heatsink compound, and I did a bit of a search to see what's the best heatsink compound, and then realising that I was just finding CPU heatsink compound, I had to qualify that and searching for the best thermal compound for transistors, and I couldn't really find anything specific. I certainly didn't find any YouTube videos on this topic. So you guys, do you have a preference? I'm thinking, why not if I buy a handful of different ones, some of the cheap ones, some of the other ones, and then do a comparison video, because I don't think it's been done before, not that I found, unless I just didn't search quite correctly. Yeah, what do you use? And do you think there's any difference between the expensive stuff and the cheap stuff? We could find out. I will mention, by the way, for CPU coolers I use this stuff, MX4, but it's a bit expensive for the amounts you would need for transistors, and I'm not sure it would make enough difference if I did use it all. I assume it's suitable because it's doing the same job, but yeah, who knows? Not me, but we can find out. So that's on there. I'll get this bolted onto here. I'll solder all the transistors on, then we can put this back together and let's see what happens. I've bolted this board back on. Always check then, guys, to make sure you don't have a short between any of the transistor collectors or the tab and the heatsink. Yeah, meter's working, just to be sure. Let's put it where you guys can see it. So that's okay. And then these ones, which are bolted to the heatsink, and this one, not sure which pin it is on those for definite, so it's normally the center one. Okay, so we don't have any shorts, so I've cleaned the solder out of the little eyelets. I'm going to try and get the transistor legs back through, and then solder these back on. Okay, and then we should be able to reassemble the amplifier. I also need to replace these resistors now. So this is where I had a burnt out resistor. I actually put these in temporarily. I have the correct size ones now. But let's see if this will now power up. So we have the current limiter there. That's only a 65 watt halogen bulb, so it may be too little current for this. Basically, I might have to put something else like my deluxe current limiter, which is 150 watts, but let's have a look. So it should at least come bright and then go dim. Well, you can see the thing rattling away. That's like a low power thing, so I'm going to connect my higher powered current limiter and we'll try again. I believe that was the relay which shorts out the thermistor down here that was rattling in actual fact. So this has two light bulbs, they're both in there. So I have, let's see, 72 watts on each one, so almost 150 watts this time. Again, the amplifier is switched on, let's see what it does. Still didn't like that. Interesting. Let's see if we have any voltage in the large capacitors. Yeah, -5, +6. So they definitely have some charge in them. It appears that this is just too much of a... In fact, it stopped after a couple of seconds. Did you hear it? Because the capacitors have charged. Yeah, look. 20. 20. So... amplifier's powering up. 60 volt, 60 volts. So we can test this. Let's take some audio into it and see what it does. And we don't need the current limiter anymore. Okay, so I've connected the speakers. I've connected my cable. I'll just put the current limiter back on, I think, just because I have the speakers connected. I now have another current path available for something nasty to happen. I just want to make sure that this is effectively charging up like it was doing before. So let's see. Yeah, it is. The lights started to go dim, so that's fine. It's also on the date of recording, Friday the 13th, so that's a very good excuse for something bad to happen. Let's just find out right now. So we'll switch it on and we'll put some music and we'll see what happens. So we switched on without the current limiter. We find some Northern Soul, of course. And I have one channel working but the other one not. Let me just check my wiring. Okay, I just switched the input cables. I switched it back on. It's actually made a funny noise, but I wasn't recording. It made a funny noise on the speaker that wasn't working, so let's see. Let's try. No, I have one speaker working and one making the occasional noise. So the one that's making the occasional noise is the channel which I repaired. So I need to look further into this one to see why that channel isn't working. I think because it's quite difficult to actually get in here while the thing's like all plugged in and connected up, probably the best bet initially is to remove the two channels. And let's see, well, first of all, I can put this channel into this side of the amplifier to make sure it's not just some ancillary winding. And if it isn't, then I can get the two boards on the bench, I think. And let's compare the two and let's see if we can see any difference. Okay, so I have the channel that wasn't working here. That's the one I repaired. Obviously not successfully at the moment. This one says okay, so that's the one that was working. I noticed one difference. This has like a little plug in here, 2 pins. This one doesn't. What I have on this one is this connector which goes to the stereo bridge switch. So it was in stereo mode, and I can see that in stereo mode it shorts together the 2 middle pins, which is where the little thing was on the other one. So if I'm just using the one channel, I'm just going to take this out of here and place it in there. And I'm going to put this amplifier module onto that side of the amplifier, and let's see what happens. To make this easier, I'm just removing all the zip ties on this little wiring loom here. I can always put some back on again. That will give me a little bit more space. It'll probably also allow me to test the amplifier on the bench if I need to, make this much easier to work on, yeah. Well, that helped a lot, because I can put this amplifier on the top here. I'm just resting it on a book as insulation, but the heatsink was actually bolted to the chassis anyway. The only cable that won't reach now is this one, which is the audio input. So I had a look at my box of various bits and found some connectors, which I've just wired up. It's worth the effort because now I can easily work on this. If I need to, I can get either channel here. Okay. This goes to here. And now we can test it. So this is the amplifier channel that wouldn't work when it was mounted in this side of the chassis. I've just made sure that the power wires don't short against anything, so this is the plus and minus HT. This one is ground in actual fact. So let's power this up and let's see what happens now. Do we get any audio? I have my current limiter attached once again. Yeah, it's fine. Okay, so power up. Well, you hear that, wow, it made like a funny noise, yeah. So there's something wrong with this amplifier. That's what I heard previously when I said it made a funny noise, but you didn't happen to hear it yourselves. I wasn't recording. So there's something amiss with this. I think the next thing I will do is compare the two to see if I can figure out if there's a difference that's fairly obvious that I can see. There's a number of ways of going about this repair, I think, or diagnosis really. First of all, we have no schematics for this. I did a previous video on this amplifier before this one, so where we actually found the fault in the output transistors and we looked at the problem with the matching. I stated on that video I couldn't find the schematic, so let's say there is no schematic. I can see there's a little part of the board here which has an op amp on. This is where the audio input comes in. Okay, I'm going to take this little thing off here so they are both the same. So I would say the audio comes in this way. This is the pot which effectively balances the amplifier, which I haven't done at the moment because, well, it doesn't work, one of them. Then we have, looks like the pre-drivers and the drivers. So then obviously your main amplifier. The circuitry at the back, I'd say this is all part of the protection circuit. There's the relay. So I don't honestly believe this is part of the problem, and it does come out of protect, by the way. The one that doesn't give any audio or makes a funny noise, it does come out of protect. The fact it makes a funny noise should tell you it's out of protect. Okay, I'll start here. In this case, I'll kind of turn this all around for me, and I'll work my way through that way. Now I'm going to do this using the multimeter in diode mode. I'm just going to see if I can spot any particular differences between the two amplifiers. Okay, the other way to do this would probably be to do it with it powered up and measuring voltages. I could do that. I could probably arrange it so I could do two side by side if I so wished, but I'd rather not poke around on the amplifier with all the high voltages if I don't particularly need to, and at the moment I don't really know where to look exactly. The other option would be to use a curve tracer. Now, a number of you guys have suggested I get a curve tracer. I have one which plugs into my oscilloscope, into my analog scope, but I've actually requested to review a standalone curve tracer, which is not so expensive as well. So that's going to be here next week, I would say. I'm going to review that. If I don't spot any difference now between the two, anything particularly obvious, this is a perfect example of a situation where a curve tracer may help you. So if I don't spot it with a multimeter in diode mode, I'm going to say, let's wait till we got the curve tracer next week. We'll make the review, and then straight afterwards we'll make a video continuing this repair. Hope you guys are happy with that. I mean, chat down there. But if we are methodical, I might be able to find some difference. To save you guys watching me, so all I'm going to do is basically I'm going to go to the same place on each one. I'll just show you as I start. For example, on this op amp, I'll go onto the negative supply, and I'll just look at the reading in diode mode. See 616, 617, 583, 583. That reads 1238 and 579. I'll do the same on this one. If you're wondering why I'm putting the red lead on the negative power rail, watch my video on a cheap and nasty way, or quick and nasty way to test op amp. So 621, 624, 581, 583, 123, 613. So what I'm actually doing, I'm just looking for differences. We can see that although there are some small differences, there's not a major difference around there. So that doesn't exactly tell me the op amp is okay, but it would tell me if there was a serious difference. If one was blown, I would see that. So that's this op amp, which is a TL071, which I think is a JFET input, TL071. So I'm going to do a similar thing, working the way through the circuit. There's another op amp, and I'm going to basically aim for all the ICs, all the diodes, and all the transistor junctions. That's what I'm going to aim for testing, and see if I can see a difference up until then. If not, the next thing I will do is go to resistance mode and measure across all the resistors. Okay, so I'll take a little bit of time and I'll let you know what I find. Okay, I've been on all the semiconductor junctions. The only thing I can spot, and it's not a difference, is if we look at this one. So we have this diode here, and you see one with like a circle emblem there on D14, and on this D14 is one of those, and that's one of those. So they're like the other way round, but if I check them with a multimeter, they look the same. So I'm not honestly sure why that is at all. but I don't think it is a fault. Yeah, you guys down there. It's just occurred to me, should have occurred to me previously, whether all the emitter resistors are okay. So I'm just on low ohms range. I could use the milliohm meter if I need, but let's have a quick look. So just gonna look at these, what I see across the resistors. Yeah, 0.5, which is what you'd expect. This is the bad one, so let's just go along these. These look okay. If one wasn't working, you expect you still get audio, just that transistor wouldn't be contributing to the load. Yeah, so these look okay. I'll check the other higher powered resistors, just let's have a look. So 14 point something there. It says it's a 15 ohm resistor according to the color code. Same here. Same here. And here. There are not many high powered resistors on this, which is what I tend to look at first. So this is a very low value. It's got a gold stripe, so that makes sense. Same. Some of the slightly bigger ones here. These are above the 40 ohm range I was on. Yeah. Look the same on both. Now let's just look at the potentiometers. So they may be set slightly different. I'm just interested to see what I see here. I can just get a good contact under there. I mean, these are prone to failure. Okay. 16.7 and 680. 16.4. So they both basically set the same, so no difference there either. I'm kind of like a little bit between a few things here. So one is that we have faulty capacitor somewhere. That kind of like weird noise on an amplifier makes me think, capacitors. So we have some capacitors on the input here. We have these here and here. I think this is all part of the protect circuit, to be honest. So we have possibility of faulty capacitors. I would have to dismantle the amplifier modules to probably just change them, to be honest. So I'd have to unsolder them to test them anyway. The other possibility I'm thinking is faulty op amp on the input. So we know that no matter which side of the amplifier we put this one, it doesn't work. So we basically know it's not something before then, you know, on the input board on the amplifier. So possibly a faulty op amp. And the other thing is to test this with the curve tracer. So I'm going to just make sure I have these values of capacitors in stock and make sure I have these op amps in stock. I mean, they're a common op amp anyway. I don't see any faulty transistors, at least with the multimeter on diode test mode. The curve tracer, I mentioned this, so that should be here next week. So let's do it that. Let's, rather than just taking these all apart again, let's wait till the curve tracer's here. It'll be a very good demonstration of that. And the op amp should turn up probably not long afterwards if we order some now. And if I don't need them, I mean, you know, TL071, very common audio op amp. I do believe it's a JFET op amp, so it won't do any harm whatsoever to order them anyway. Okay guys, so long enough for one video. Still not fixed, but not blowing fuses anymore at least, so we got somewhere. Yeah, let's talk about it down there. Any of your suggestions for the next installment, and let's see what we can do. Okay, hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.